Hello there, welcome to the wonderful world of radio frequency and electronics engineering. On the bench for repair today is an ICOM communications receiver, IC7000. The reported fault with this is no display at all, nothing, and we haven't got the backlight showing on the meter. It also makes an awful buzzing sound and does nothing apparently. This has been owned by a previous radio amateur who has also had a go at repairing it, and we do have a service manual for it here in paper format in a binder which we'll be using as part of this repair. Now, these communications receivers manufactured in the early 1980s and it boasts a frequency range of 25 MHz to 2 GHz. Now, this receiver can receive AM, FM narrow, FM wide, SSB modes, lower sideband and upper sideband. So it's a great receiver, and when we've repaired it later on in the video, you'll see it used on an antenna that I have here, and we'll be listening to signals outside from all over the world, plus local communications as well, and demonstrate its features. Now, bearing in mind, back in the 1980s, this was a top-of-the-range receiver. It was even purchased by militaries around the world. Another manufacturer that was about at the time, which made high-end receivers like this, was AOR. Now, it was commonplace at the time to see these receivers in publications like scanner guides, HF and radio communication publications, where the ICOM R7000 appeared many times in pictures and descriptions. And I remember these coming out. They were very, very expensive. There's no way I could afford one of these when it first came out, a bit like the AOR 3000 receiver as well. That was very expensive, and yet the AOR 3000 scanner receiver appeared in the Jane's defence manuals, which militaries then purchased from. So naturally, high-end receivers, because back in the 1980s it was quite difficult to get a receiver or a scanner that could cover more than 512 MHz. It wasn't until around about the late 80s, early 1990s when manufacturers such as Realistic, UP2, Uniden and other at the cheap end of the market, if you like, started delving into the plus 900 MHz range to 1300 MHz, just so they could fit the cellular bands in, which back then were analog. So there was a big market in people buying receivers to listening to mobile phones on the cellular networks before they went digital. So there's obviously a big push on that. But these were the creme de la creme of radio receivers. Another manufacturer at the time as well, very popular with communication receivers, was Kenwood, and I do have one here to show you, which is an R5000. Now this is a HF receiver, and you can get an option on this when you press the VHF button on the front here that's down there. There's a VHF button that allows you to select the VHF frequency range of 136 to 174, I think it is. But again, beautiful, both of them, radio receivers. You don't get things like this anymore. I mean, the buttons are made of chrome, there's chrome finishes on the knobs, all metal casings and beautifully constructed, and none of this garbage that you get today even comes near this. The quality and the workmanship and the switches, all the quality of the buttons being chrome, and the display and so clear when they work, and you know, wonderful specification as well. A lot of emphasis went into these receivers with design to introduce things like bandpass filtering at the front end. I mean, this was in the days when Varactor tuning of bandpass filtering wasn't really found in commercial gear. It was mainly found in military kind of equipment, and rather than capacitive tuning using trimmer capacitors on most receivers, this used instead Varactor tuning. And there's quite a lot of advances in these in terms of technology in the day. So wonderful examples, these two, of that era from the 1980s in communication receiver technology. Again, these receivers often appeared in publications around the world. Very, very expensive though, that's the only thing. And I remember when I was quite young and I saved up my pocket money, I went to a radio rally here in England where there were many radio rallies held weekly across the country, and some of the biggest rallies that I used to go to, like Drayton Manor, Elveston Castle, which are long stopped running now, but we still have radio rallies here. I went there with some friends to buy an AOR3000 receiver, and I'd saved up for a very long time because, as I say, these receivers were very expensive to buy. And I went with some friends to this rally, and I saw an AOR3000 scanner. It wasn't cheap, but it was like new, and it had the box and manual and everything. And I made the purchase. It was very expensive, and I thought it was a bit light, and but not owning a scanner like that before, an AOR3000, it wasn't too light, but it wasn't too heavy. But I thought there was something a bit weird at the time. The guy who sold it me was a trader, and he said, oh, no problem, it's all working. It's come from an elderly gentleman that's had to go into a home, unfortunately, and it seemed to have a good story behind it. But I made the fatal mistake of not having it demonstrated and powered on, and I bought it. I got it home anyway, plugged it in, and nothing happened. There was no display or anything on the receiver. Anyway, I took the lid off to have a look inside. Bear in mind I'm only a teenager. I had a look inside, and the boards are missing inside, top and bottom, completely and utterly empty. The only board that was in it was a keypad board for the front with the display. So I was gutted. Anyway, I'd lost my money. There was no way I could, get that back, and that was it. It's the only time I've really been duped. Anyway, that's what I always recommend when you get receivers or radio communications equipment. Before you hand your money over, always test the receiver before you take it to make sure that it works, either with another radio, handheld or whatever, to test that it receives by holding the radio nearby, or just make sure it powers up and everything seems to work, and you can tune into a broadcast station or whatever if it's a receiver, a scanner, or a receiver like this. Sometimes, you can fall foul, as I've done in the past. It's not often, and I bought a Yaesu 736 communications transceiver recently, a 50 megahertz one, 144, 70 sems, 430 megs, and 23 sems, 1296 to 1300 megahertz transceiver. And I bought that in good faith. The guy said it didn't work on mains, but it did work okay on DC. Got it home, plugged it in. It came boxed with the manuals and everything, a microphone. It's a transceiver. Anyway, it worked fine on DC, as he said, but when he plugged the mains IEC lead in the back and powered it from mains, there was nothing. So again, took the lid off that, had a look inside, and the power supply was missing in it. Totally missing. And I think what had happened is perhaps the power supply had failed. Somebody had gone in it, removed the power supply with good intentions, perhaps repairing it. This particular radio transceiver I'm talking about came from somebody who had sadly passed away, and it was the family selling it off via some radio club. And I purchased it believing the power supply would still be in it, but perhaps faulty. Anyway, unfortunately, as I've said, it wasn't in there. So again, when things like that happen to you, it can cause a lot of aggro trying to replace that part, because obviously parts are very difficult to come by, particularly on older radios. So always be careful with that, and if you buy something where somebody's had a go at it beforehand, always take the lid off first and have a look inside before you power it up. Because I've seen all kinds of things over the years. I've seen KitKat foil covering fuses. I've seen, as we said there, missing boards. I've seen wires for mains just left dangling in the breeze inside, touching things because somebody's unplugged them. I've obviously seen nails in place of fuses. All sorts of horrifying things, cables just left floating about and touching case parts, and oh, you won't believe it. I've seen all sorts. So it's always worth testing a radio before you buy it, before you hand your cash over. And if you buy a radio that's perhaps been looked at prior, try and get as much background information as you can before you buy it. And if you're not confident about it, ask the owner if you can take the lid off to have a look inside, just to make sure and verify there's nothing missing internally. So that's what we're going to do with this receiver before we plug it into mains. Because, as I said, another radio amateur owned it before me. They have owned up and said there've been fault finding on it, hence the reason why the manual came with it. So that's what we need to do. Let's open it up, check inside first before we go any further. Okay, so we're ready to confirm the fault that's been reported, which is buzzing sound and no power. So we've got it plugged into the mains. We'll just hit the power button. Got the sport seems to be working. AM, FM now. SSB mode. But yet we've got no... I can't see a backlight. Now, there's no backlight on there, but that's nothing to worry too much about, because little rice bulb that illuminates that, they often blow. But there's definitely no display. Sometimes you get dry contacts on the dimmer switch, but there's nothing there. There's nothing in that display either, if it is a display. But yeah, looks like the keyboard's working. And every time I type in a frequency, which I might do 145.550, enter. Right, if I type in now, I've got my other radio here, which I can transmit on to double check. Rather than turning the test set on, I can just radio test. Yeah, so that works. So it is receiving, because obviously I've just put my other radio on and transmitted there on 145.550 megahertz, and we heard it come through. So it is functioning in receive. It's just the display isn't working. But he definitely said that it buzzes. All it does is buzz. It doesn't work. Nothing works apart from buzzing. But, as we can see, it's definitely working. Sometimes I say, you know, you get like, do that a few times on these dimmer switches and the display will fire up. But in either position, the display should be on anyway. So there's something wrong. And that. So what's this? Oh, hang on. Hang on. Yeah, because no screws in, but... Something not right there, is there? Just... Something touching something and cutting the audio off there. So there's definitely something wrong inside, so we'll have to get the lid off now and have a look a bit closer, I think. But yeah, there's definitely a buzz there. Don't want to tempt Providence by keeping it on for too long, just in case it's shorting it out, you know, when I press that down. But yeah, so we'll have a look at the service manual as well, because I'm not sure whether or not you know, it's I can't see it being that speaker, but no, it's not the speaker. It's when I touch that metal frame thing inside. That circuit board there. There's a PCB just inside. There, look. Right. So that seems to be an issue. Okay, well, we'll have a look at the manual next anyway and see what that says. But if I start stripping it down, because even before we press that down, that case, there's no display, obviously, no backlight behind the display there, so it could be just a loss of a power supply rail. I have noticed as well this knob on this controller in the bottom there does seem a little bit skewed. I wonder if it's been dropped or banged, this corner. It's only slightly out of line, but I could see it. So we'll see. But yeah, it could be a loss of a supply rail internally. As I said, there's that DC to DC converter module, and that could be Could be that there's a loss of supply on that. It could also be caused through a short when we press that down. As you can, something definitely going off, and that it's definitely this board which goes along behind the display there. So definitely looks to me like the touch sensitive part is a fault on the front, possibly. However, we've still got a power supply issue. I think the receiver's working, because obviously if I talk on my radio, 1 2 3 4 5, this is a radio test, testing. So as you can hear, nothing wrong with the receiver. Well, yeah, at least it's picking up in here anyway, so we'll do some proper confirmatory checks with the Marconi later when we get it repaired. But no displays at all, so let's see what we find now. Okay, so let's have a look, see if we can, because we've already taken the screws off. That's promising. At least there's some boards in it. I'll just disconnect the speaker lead, which goes to the main board. Remove the casing carefully. Put it to one side. Oh, all looks well so far. We've just got a module at the end there, and then on the inside as well we've got no missing boards there. Receiver board, more cans. There's another module just here on the other side, which is there. That's all complete. All looks okay. I haven't seen the mains power supply yet. I think last time I repaired one of these, it's underneath. I think it's in this section. Let's just have a look here and just carefully remove this this case part. Here we are, look, got the good old mains power supply. The fuse is intact with the look of it. Got quite a nice transformer. I don't often see transformers like that with the two different field windings. It's like a toroidal transformer, but it's a laminate core rather than a ferrite core, but it's designed in the style of a toroidal transformer, obviously for low profile. You don't often get those like that, but it's in good condition. We've got the smoothing capacitor there, the reservoir smoothing capacitor. I can see a bridge rectifier just at the back there, bolted onto the heat sink. The KBU 6D device, and then just below it, sort of at an angle down there, just sandwiched right at the bottom, it looks like a regulator transistor bolted to the chassis back for heat sinking. And it looks like we've got a connector here with a link in it, so I'm not sure what this is. It looks like as if the output of the power supply looks like a 13.8 volt output's linked back on itself. I think when I've repaired one of these before many years ago, I think you could have an option on the back, I think somewhere here on this plate for DC in. That's why that blanking plate excuse me. So I think that could be connected to the back there, so you could feed DC in. That's what that's for, 13.8 volts. So we've got a few components on the regulator board, potentiometer down there, that white thing right down at the bottom, which between the cap and the little cap and the big cap, for setting the voltage with the look of it, output voltage. This space here is not blank because there's a board missing as such, or well, there is a board missing, but it's not for the main operation of the unit. There's an optional speech synthesizer module goes in here, which is what this connector's for. That's been taken down at the factory, so I know that's correct. This, if I remember rightly, is a DC to DC converter, so the 13.8 volt output from this power supply provides supply to the whole unit, but as well as that, there's a supply comes into here, and this derives multiple supply rails. I think it's minus this and that voltage, 7, 5, 9, whatever, 12, 15 volt rails coming out, and some plus volt rails. It's like an inverter, a DC to DC converter. So we'll do some measurements on that as well, if we can confirm this customer's fault of it not powering up and just buzzing, as well as checking the power supply. But yeah, everything's there. The display board, the control board at the front, that's all there. Everything's all plugged in. I can't see anything obvious like any looms or anything disconnected anywhere on the radio at all. It's all intact as it should be, no broken wires, although there's a white wire there though that looks like it's that white wire down there. I don't know if it's just me, but it looks like it's quite loose, but it isn't. No, it's alright, it's okay, it's just a little wire down here. It just like didn't seem right, but it is. We've got the backlight bulb for the meter, the moving meter, and obviously the LCD display is mounted on the front. We've got this board here which looks to be wobbly a bit, but looks okay. And then we've got this board here that looks all okay to me, to be honest with you. Nothing that I could see that definitely stands out as being a fault as such. So yeah, so now that we know that the main power supply and its connections coming in from the fuse and everything's all as it should be, there's nothing to worry about in this area as to a potential you know, catastrophe occurring. There's no foil covering the fuse, there's no, you know, cables loosely touching things. So that's all we need to know. Now we can plug mains in and see how we go on. Have a look at the see if we can confirm the fault condition with a customer which reported buzzing all the time and no power. Okay, so just thought we'd have a look at the service manual, see what it says about this receiver. It says the most sophisticated continuous coverage receiver on the market today, the ICOM R7000, is a result of both advanced ICOM engineering and state-of-the-art computer interface technology from ICOM, such as the new IC or CI-V system, a feature that allows for easy and convenient computer control of your ICOM R7000. Equipped with 99 internal memories that are completely owner-programmable, the ICOM R7000 is unmatched in scanning and coverage versatility within the 25 to 1300 MHz range, and may even cover frequencies up to 2 GHz. Low band, aircraft, marine, business, FM, amateur radio, emergency services, government television bands are all conveniently available and immediately accessible with the ICOM R7000. It talks about there being 6 variants of it, well actually 5 variants. It says 5 separate versions of the ICOM R7000 have been designed for use in the USA, Europe, France, Australia and Germany. This service manual covers every version, so obviously there's some slight differences in them when we look at them. But anyway, I've highlighted some pages in this manual that we can take a look at, because I've put a bookmark in, which is this here. So just pull these back, these pages. So we've got the power supply section down here at the bottom, which is what we're looking at in the bottom rear section. So we've obviously got, you know, that there. We'll measure the voltage coming out of this because I suspect that there potentially could be an issue with the power supply maybe. So we'll definitely check this. But there is another module, a DC to DC converter. So that's the main power supply. Obviously we've got the mains input coming in on the IEC socket at the back, followed by, if I can get that to just focus on it a little bit. So we've got the mains IEC, then comes into an international voltage selector, select different taps. Then we've got secondary into a bridge rectifier, obviously then smooth with the big fat electrolytic cap we saw, the fuse. Then we've got the voltage regulator circuit there, the series pass transistor, which we saw bolted to the back of the radio. and then ultimately it comes to that socket that we had where we had that little pull cord on it, and we've got a link through then obviously, which gives us 13.8 volts out to the via this inductor to the output there, which goes off to feed the rest of the radio. So that's a main power supply. So if I have a look a bit further down here, oh here we are, DC to DC unit. So this is that unit that was on the underside under that small can. It was near the option board. So we have supplying this unit the bottom rail here at 13.8 volts at the top of this socket here. That goes through this connector to this inductor to the center tap of this transformer on the primary side, and these two transistors there essentially switch each side down to ground respectively, generates higher voltage on the output, which is then rectified via D1 and D3, and then these two act as voltage regulators, as well as in this case this particular one is a minus voltage regulator because we've got the diode in reverse. So we've got 3 voltage regulators which give minus 12, minus 7 and plus 24 volts DC out as well. So this module's of particular importance. We're going to have to measure the voltage. Obviously the other power supply we just looked at prior supplies 13.8 volts into this, so that's a major thing, is that. As for the bulb not coming on behind the display itself, well, it could be the bulb popped, but we can check the voltage to it. I would have thought though, had we had a major supply loss, the receiver wouldn't be working at all, so I'm thinking there's probably two things here going on. There may be the bulb itself has popped, that illuminates the display. So this is a bulb here. It's controlled by this dimmer circuit, which is a bit further down. There's a little dimmer circuit, which is just here in this area, which comprises of a push button switch on the front and some series resistors down to ground, which, depending on which position you set this switch, depends whether the ground side of a lamp is either taken direct to ground via this outer tap here to ground, or whether it goes via the resistors ultimately to reduce the voltage, but just dim the bulb effectively. We've got a 13.8 volt rail here that comes up from down below, comes in, jumps back out and then goes up to the bulb, and then the other side of the bulb which comes out is then connected to this, obviously this switch. So I can see how that works. It's not obvious how the display is powered though, unless I'm looking really carefully. Oh yeah, we've got a 13.8 volt rail coming in there. Look on the, is that right? I'm just using my magnifier. Yeah, we've got a 13.8 volt rail coming in on the far right there into this display unit. Again, we've got two cables here, two wires which go off to this dimmer switch. The dimmer switch is broken into two halves, a lower half and upper half. The lower half of the switch is used for the bulb, for the meter, the moving coil meter, which is there. The top half is going into the display board to then reduce the voltage, obviously, switch it in and out for the display unit. So we have a 13.8 volts DC input on the right there going in. We've got the strobe lines there that are multiplexed for the segments of a display, and then we've got particular parts of a display which illuminate for things like AM, FM, FM narrow, SSB, etc., which is illuminated by these inputs there. So that's for those, and scan and various other things. So there are particular segments in the display that are illuminated by these contacts as well. So it could be the 13.8 volt rail to both the display unit and perhaps the backlight bulb is missing, in which case that explains why the processor works. That will be in the logic unit with the keypad, and it programs the synthesizer, and the receiver works. And it could be that there's a supply rail gone to the display and that bulb. Even if a bulb's gone, it could be that there's no display power. They certainly didn't look it earlier anyway. It's not even dimly lit either, so I think there's 13.8 volts missing to that. As I said, the processor's running, so it's not as if a processor's not running and it's not then outputting to the display, because then the rest of the radio wouldn't work, obviously, and it does, as we've proved. So yeah, that 13.8 volt rail, it seems to go, if I'm looking at this right, it seems to come down from there. It goes, there's too many lines. Oh, there we are. Look, it comes out, curves to come down. It goes to this rail here, comes along, and then it becomes a second down from this point. So where does that go then? Well, look, next drawing. So that's this rail here, the second down from there, and it goes all the way up. If I can just see that, it goes all the way up, and then it goes into there, and there's a 13.8 volt rail there. So there's a 13.8, goes along, and it actually links to that little dot there, which also supplies this voltage regulator, and also continues to come down and then supply another voltage regulator further down. So if I just zoom out, you might be able to see that a little bit better, although it's difficult with this camera. But it supplies this voltage regulator and that voltage regulator. The left side of these regulators an input, so that's not a 13.8 volt rail that's being supplied in there. It's literally coming from within this board, coming out to our display board and meter backlight bulb, but it's also tapped in to supply these two voltage regulators and other parts of the circuit as well. So the 13.8 volts will be derived, will be linked in that board from the power supply, and it'll go through various circuits, I would have thought, in order to get into there. Because we've got the DC unit as well. The DC unit supplies power to that board as well as the main AC voltage power supply, which has a fixed 13.8 volt DC output. So they'll link into this board and then obviously supply various components in there, as well as coming out as an output coming out of here to supply other circuits. So we'll have to check on this board to see 13.8 volts is leaving this board, which is the main unit. That's what it's called. It's called the main unit. So we'll have to check that, as well as the DC to DC converter. Might start with the power supply first. Always start with the power supply, because there's no point delving into the rest of the system until you check the power supply. So we'll start at basics right from the beginning, go from the power supply then to the DC to DC converter, check that out, and then from the DC to DC converter to the main unit, check that out, and then the output from the main unit, then leading off to the displays and the display unit and the backlight bulb, and see whether the 13.8's arrive in there too. So I think that'd be a good place to start. I think there's some theory of operation that describes what how the circuit operates, which I'll find and we'll have a read at that. Okay, so I found a bit of a theory of operation in the service manual that tells us how the power supply section works. And it says here the regulator circuit reg unit, which is the AC power source, which is in the bottom rear we were looking at earlier, that big transformer. It says voltage, it says the AC power source from the AC power socket is fed to T1, transformer 1. Voltage from T1 is rectified by bridge rectifier diode 1. Next, it is then fed to the stabilisation circuit consisting of Q1, Q2 and Q3, and then is supplied to other circuits. which is the 13.8 volt rail going out. It only has one output. And then it says here the DC to DC converter module, which is the little module we looked at underneath. And we looked at the diagram just a moment ago for it. This circuit converts 13.8 volts DC from the reg unit to -7, -12 and +24 volts DC voltage. The circuit consists of an oscillation circuit, a voltage step-up-down transformer and 3 regulator circuits. So that's all it writes about that, but I did find something just a few seconds ago about the display and how that works. And it did mention, I think, something in there about the power supply. And it said about the display circuit to the display unit. The circuit consists of a fluorescent display tube DS1, display tube drivers IC1, IC2 and a DC to DC converter circuit. So yes, interesting. It says frequency display circuit. IC1 drives the display of the frequencies, while IC2 drives the display of memory channels. So there's 2 ICs, one for the frequencies and one for memory channels. The signals from the logic unit, the main unit, control IC1, IC2. So yeah, it doesn't say much else about that. So there is a DC to DC converter circuit within the display circuit in the unit, display unit rather. So yeah, this is a couple of things there. So we are digging deeper and we're getting to know more knowledge about how it works. So yeah, I think what we need to do now is start measuring voltages and take it from there. Okay, well, we're joined by the technical manager now, who's interjected at this stage of the video, and we are just before we look at the voltages in the power supply section that we were looking at earlier in the last part of the video. We were discussing that. I noticed, obviously, when you press down on the top of this frame here, it was shorting something out. It appeared to be doing that. And I noticed something out my eye corner, which I hadn't seen earlier in the video, but just sort of stood out. And if you remember, there was a screening can. There was a PCB on the back of here, and there was a screening can over it, and it seemed to move. And that's the screening can there with this tape, which is meant to cover a flexible circuit. So that goes on the back of there like that, and this tape that you can see here was bent round underneath and it didn't look right. Anyway, I've removed this board, so if we zoom in a bit more so we can see that. And obviously somebody, as I said, had a go at this prior, because when we look at this board here, there's a bit of soldering work being done on these wires there, which you might be able to see, these wires, and looks a bit how are you doing. And then the foil, which is on this screening can here, actually goes with this flexi. So that foil bends underneath this flexi, which goes to the display. But more worryingly, if I just zoom in here, you've obviously got the display unit, but as you can see, it's loose in the housing. So somebody, you know, has obviously had this out, and it's loose in all manner, so horizontally and vertically, and it's not very good, is that? It's obviously not being reassembled properly. So I'm going to have to take that out. I'm not happy about that. And obviously that short circuit was happening with this foil end here, because this edge of this foil on the very bottom there was making contact with the circuit board here. It was bent over this area, probably touching things like this area there, and other parts of the circuit that it shouldn't be touching. So it wasn't stuck underneath here, you see, to the ends of this strip, and it should be glued to that or taped to it, and it was touching down here somewhere. So that'll probably explain why when we pushed on the frame and this moved about with the tape on the screening can that covers that it was sort of touching things that it shouldn't have been. So again, yeah, that's not particularly good. So on here we've got the display driver ICs down there as well, so hopefully, you know, we can get that repaired and get the display to illuminate again. Hopefully the display hasn't gone pop, but there's a little glass nibble on the end of that, a little glass nib, which is still intact, thank goodness. So I'm just working out now to get this display out. I think you undo these two screws at the top and then this metal thing comes off, but I'm not 100% certain yet. So I just need to get this board out, just to have a good look at it and inspect the printed circuit and look at it more closely to see if there's anything obvious before we go any further. Well, the plot thickens. We've removed this bracketry, which gets rid of, that's a bit of a solder spot there actually on this display. Bit of hot solder's flicked off onto this display there on the back. It's just stuck to that lens, so we'll have to get that off somehow. But anyway, I've got a wire flapping around in the breeze, which is this wire here, so that's obviously come off and touching whatever it shouldn't be. And this is a display unit, and all looks good. It all looks good. Technical manager's giving some advice, but yeah, very strange. This part of this bracket here looks like it's had some sticky tape on it, which the display rear obviously glues to, and you can see the tapes there and there. So at least that's nothing too much to worry about. It's not like as if there's been some packing missing or anything like that. It's just simply stuck to these. So that's put my mind at rest a little bit. So I suppose it's just a case now of finding out where that wire goes, which may answer the reason why it's not powering up, but I don't know what these wires do at the moment. So I'm gonna have to find out that and then look at it further. I don't particularly want to power the unit up until we sort of get that sorted out, obviously, in case it blows something up, or it may have already done that, and which is causing one of the supply lines. So I just need to resolve this issue, insulate it all, or put it back together at least in such a fashion where at least we can measure on this board, protect it from shorts, and then start doing voltage measurements then on the rest of the unit. But yeah, it's obvious now at this stage someone else has had this apart and got down to this level for this solder spot to be on the display, or somebody's flicked the soldering iron and what have you. Somebody's had a go at it. So hopefully the display's okay and it's not broken. I don't think it will be, but you never know, do you? So we will see. Well, I finally got the answers. If we zoom in a bit here, we'll be able to see that these wires are bridging this flexible printed circuit board. So somebody soldered some wires just there on the top here and then linking them to the actual display module down there. So this must have had perhaps a broken track in it or something. So not sure if I've carried out a successful repair when that was soldered in the right position and the display came on. So that's always a possibility. So I think it'll be time just to run a quick check on this display unit. Obviously we'll have to test each connection from one end to the other and sort of wiggle this about at the same time just to see whether there's a broken connection here when it's folded up as its correct positioning in the front of the unit. So I'll give that a whirl and see what if anything that reveals. It's just one of those things, I'm afraid, with this. You know, somebody else has had a go, you don't know what they've done, and there could be shorts and bits of wires we've seen here hanging off, and all sorts of little problems here that they could have caused. Blown something as well further on in the unit when this repair was done, if this wire's come off after they've done that repair. So, but we are getting into the deep level of it now, so shouldn't be long before we actually get some sign of life out of it, hopefully. Okay, so what I did, I soldered the grey wire on. As I did that, the yellow wire came off, so I had to solder that on as well. And then, yeah, so it's a bit how you're doing. But, yeah, I've noticed something anyway, which you just highlight how careful you've got to be with these things. So I'll just zoom in, I'll put my magnifier on, because obviously somebody's soldered all these as well. So we'll just go over to the magnifier, and then if I go right in, we can see my wonderful soldering there on the grey wire in particular. The purple and yellow wires were soldered on beforehand, although the yellow came off. So I've basically soldered the grey and yellow wire on myself, and then the purple wire and the wire at the end there, he's been soldered on prior to me, but it's not too bad that. Although the wire length on this purple wire here, I think I'm going to have to shorten that so it can't touch anything. But anyway, as we go along, because I digress, you can see the solder terminals, and voila, here we are, look. Again, you see, this is a sort of thing where you've got this poor attention to detail, which is obviously solder splatter there. It's connected those two islands together. So that's that. If we keep going, you'll notice as well, occasionally you'll see what appears to be like all the sort of solder debris around the islands, which some of them are quite bad. Anyway, as we get going along, everything else looks better at this end. Let's keep going along there. Doesn't look too bad, to be honest with you. That looks okay. That looks okay as well. Yeah, not too bad. Not too bad. Keep going. Just rearrange the light a bit better, I think so. And I think we've got to the end there anyway. So, yeah, looks okay, to be honest with you. Not major issue. Just needs cleaning and a bit of a resolder of those shorted pins. You know, just remove the excess solder. And some of these islands look a bit dry, like that one there in the middle. That looks as if it's a bit of a dry joint to me, that, with the way that the solder's flowed. So it might be worth me resoldering them all anyway, and sucking the old solder off, and then resoldering and putting some new solder on, just to renew it, because you've got this sort of shiny crevices that are on it, and it doesn't look too good quality, the solder. That looks a bit dicey. That there looks like some kind of little, where is it there? That's it. Looks like some kind of little island or something round it, as if it's broken, the connection there, as you can see. So if we just zoom in a bit more, I'm just trying to get the so precise. That looks like it's cracked around that little island there, so we'll have to resolder that. And so does its neighbour a little bit there, but sometimes it's an optical illusion when you're zooming in on things, especially with the shadows that are cast from lights, and magnifiers make things look 10 times as worse. But that's definitely a no-no, is that. Well, obviously, if that's on the heater for the display or something like that, it'll obviously cause the display to not work. And yeah, just looking a bit further there, it looks okay. Lots of debris and what have you around it. And then we've got the wires again, which look awful under the microscope, but to the naked eye they look fine. And that thing, we've got half a mile of cable still exposed, so that'll have to be redone. That's not too bad. So we could potentially have a look at the other side now, which is this PCB here, and that doesn't look too good at all with the purple wire. This purple wire here. Yeah, that purple wire is definitely, oh, look at that. That's shocking, is that, isn't it? Absolutely shocking. That'll touch all sorts of things, that will, won't it? Not too good at all. They look too, that one looks like it's had a bit of soldering work done on it. Just keep going. Yeah, a few solder flickers on that one. It's not too bad though, I've seen worse. Yeah, that one's had a solder job on it, look. So there's been a few little bits and bobs going on here, I think, with this repair. It don't look too bad, this side anyway. I think we're going to be okay, to be honest. I'll be struggling to try and find a reason to start hacking away at this side of the circuit. So yeah, looks like it's just a bit more attention to detail with the soldering of these connections, and repair the wires, especially on this side as well now, before we do any tests, and have a look at it, wash it down with some isopropanol alcohol after we've done the resoldering, and have another look again just to make sure that there's nothing touching before we reassemble it and power it up and see whether, you know, the display comes on. Probably try and power it up with the display out the front at the moment, just so that we can verify it when it comes on, and take it from there. You know what the saying is, if it ain't broke, don't fix it. So let's see whether we can get the display running before we put it back in the case front, and then at least then we know where we're at. Okay, so we've resoldered the flex, we've sucked all the old solder off and resoldered it and cleaned it up. We removed those wires because it still had continuity between there and there, even though the wires were in place. So I've removed them because there was no need, there was continuity there, it was fine. Now when you're doing a job with the flex, you really need your soldering iron and solder suckers to be on a low temperature. About 370 degrees will do it, because any higher, like 400 plus degrees, then you know you're going to burn this flexi strip up quite badly and destroy it. You certainly don't want an iron like that on it, you know, doing any work like that. So yeah, you've got to be really careful. So we'll just quickly scan the connections now, just have a look at my soldering work and just see. So we'll put the magnifier on, and we'll just zoom in a little, and then we'll just quickly go through and scan the connections. So looks like as if we're all okay here with the look of it, right the way down. If you remember earlier, we had a couple of eyelets showing and dry solder joints, but all that's gone now. I've done my best to clean up using a toothbrush between the islands, you know, just to shine them up as best we can, remove as much of the flux residue as possible. There's still a little bit remaining, and so I'll give it another clean again before reassemble it. But just wanted to make sure I've not put any solder slivers on myself, because it's so easy with these solder connections just for a little bridge to go between them, and you'll be surprised just how easy it is. Unless you look under a magnifier, you'll never see them. So yeah, that's looking okay to me. Is that looking quite clean and tidy, and that's the end pin there. So yeah, we can quickly go through some tests anyway and highlight it. There's a couple of little bits that I just need to clean up, just remove these little solder slivers and things that have occurred so they don't contaminate the board again. Lots of little bits of mess and things that I just need to finally clear up. I think I'll just do some continuity checks with this flex, see how it looks. But yeah, looking a lot better now than before. So we'll just run through that, I think, see where we get to. Right, we'll just have a quick continuity check on this flex. I mean, these things can drive you up the wall, because you often get this situation where you get like a dry joint syndrome or a open circuit syndrome, because if you don't clean the residue, the flux residue off the islands on either side, it coats it with like a film, and basically it becomes sort of non-conductive then. So then you put your probes on and you suddenly find that you know, there's no no continuity at all, and then it can lead you down this merry dance of convincing yourself you've got a broken connection when you haven't. So you start soldering wires and things like that across, and you can get tricked. You know, it's like a magic show. So you've got to be careful that you just make sure you clean everything as much as you can with alcohol cleaner or circuit cleaner, and just make sure that all the connections are clean. You've only got to have a little tiny bit of contamination somewhere, and then it insulates the connection that you make with the meter. So it's so easily done. And depending on your probe size as well, that's something else, where your probes, if they're too fat, they can bridge connections, or if they haven't got nice sharp pointy ends in them like these have got quite almost like spike ends on them that really sort of make an indentation into the solder itself. So they're like little needles at the end, and those type of probes are the best sort, because they get through some of this encapsulant that makes it onto the onto the solder blob itself on the island. So yeah, you've always got to be a bit careful with things like that, otherwise you'll just drive yourself up the wall, convince yourself you've got broken connections. And like here now, I've got a bit of a dodgy connection there, which is just down to me with the probes, that's all, on that particular connection. So again, it's just one of these things that you've got to look out for when you're doing them, because they're so difficult to measure, and the fact that the thing moves as well as you're trying to measure it makes it even more difficult. So you can end up, especially if you're tired and you've had enough, and perhaps things have got a bit on top of you with regards to tracing the fault and convincing yourself that there are things wrong that maybe aren't wrong, and then you can sort of convince yourself that the flex is broken, and in actual fact it isn't broken at all. And of course, depending how the flex is soldered as well, with the islands on the right side of the picture, a lot easier to get onto than the islands on the left side where the red probes connect into. And because they're vertically stood out the board as opposed to being horizontal like the islands that the black probe are connecting to, so you end up slipping off pins and not being able to make contact, and and then you sort of drive yourself up the wall. So just measuring these last one, I've got that one there, there's one more next to it which I've got, and then the end pin. And it's funny because on the end pin there, I'm not actually getting any continuity, would you believe? Let's just double check that. Right, so we've got continuity there, second pin, nothing on the second pin, and nothing on the end pin either. So I need to look at those. So the third pin in, 1, 2, 3, I've got continuity, but the last two I haven't got anything there. So I'm going to have to look at that and find out what's gone on. It's the thickest track of them all, would you believe? So just have a closer look at that. So it looks like the end connection's open circuit. Yeah, so if I go on to let's have a look here. Just zoom in a bit maybe. Right, if I go into 1, 2, 3, third one in, 1, 2, 3. I've got continuity on the let's have a look. 1, 2, 3, third pin in. Yeah, I'm on that. So if I can get on it, seems to be a bit temperamental, but 1, 2, then that, and then that there. So I've got third in from the end, 4.4 ohms roughly. But the second one to the end, nothing at all. And then the end one, I had some connection earlier. It varies about 14 ohms and then goes back to nothing. So that big thick track is definitely open circuit. and then the second one in, definitely open circuit. Yeah, so looks to me like as if third one is okay. So it's just the last two on the end of there. So I think I'll put some enamel wire in and bridge them. I can actually see just underneath the it's very difficult to see unless we've got the magnifier, but right underneath that flexi there where it connects to these islands, there's like a crack. You've got like an island that's floating on the print, and then where it solders to these connections, the island sort of cracked away from the flex. So obviously that seems to be the issue, but some enamelled wire I think, and then we'll do a good job of those last two connections, and we'll recheck. Sometimes these can be a nightmare because the moment you start bending them into different positions, then they'll be intermittent with all the connections. But I've had a good look at this and I've bent it a few times to see where I can get the connection to break or make, but I can't on any of the other pins apart from these two at the end. The end pin does sometimes read about 14 ohms and then it goes open circuit totally, so these two ends have obviously got a bit of an issue. But if I power it up out the radio like it is now, and we get a display on there, I can move it around to check that the display doesn't go on and off, or certain segments appear and disappear, so I can do that. But it could be more, because these are thicker tracks at the end, they could be the heaters for the display. So naturally if the heaters are not working and the voltages are not there that need to be there, then it won't illuminate anyway. So right, we'll do a little repair on that now. Yeah, so if I go on to let's have a look here. Just zoom in a bit maybe. Right, if I go into 1, 2, 3, third one in, 1, 2, 3. I've got continuity on the let's have a look. 1, 2, 3, third pin in. Yeah, I'm on that. So if I can get on it, seems to be a bit temperamental, but 1, 2, then that, and then that there. So I've got third in from the end, 4.4 ohms roughly, but the second one to the end, nothing at all. And then the end one, I had some connection earlier. It varies about 14 ohms and then goes back to nothing. So that big thick track is definitely open circuit. And then the second one in, definitely open circuit. Yeah, so looks to me like as if third one is okay. So it's just the last two on the end of there. So I think I'll put some enamel wire in and bridge them. I can actually see just underneath the it's very difficult to see unless we've got the magnifier, but right underneath that flexi there where it connects to these islands, there's like a crack. You've got like an island that's floating on the print, and then where it solders to these connections, the island sort of cracked away from the flex. So obviously that seems to be the issue, but some enamelled wire I think, and then we'll do a good job of those last two connections, and we'll recheck. Sometimes these can be a nightmare because the moment you start bending them into different positions, then they'll be intermittent with all the connections. But I've had a good look at this and I've bent it a few times to see where I can get the connection to break or make, but I can't on any of the other pins apart from these two at the end. The end pin does sometimes read about 14 ohms and then it goes open circuit totally, so these two ends have obviously got a bit of an issue. But if I power it up out the radio like it is now, and we get a display on there, I can move it around to check that the display doesn't go on and off, or certain segments appear and disappear, so I can do that. But it could be more, because these are thicker tracks at the end, they could be the heaters for the display. So naturally, if the heaters are not working and the voltages are not there that need to be there, then it won't illuminate anyway. So right, we'll do a little repair on that now. Okay, we put some enamelled wires in now anyway, so we're good to go. Tested continuity, everything's fine as it should be, and it's just a case of making sure everything's nice and then turning it on, seeing what we get. Okay, so the radio's on now, but there's still no display there. We've still not got the backlight bulb at the rear here lighting up, so I think we've definitely got a power supply issue, because obviously I've put it back together, and I've also put the on the back there's some screws that hold the PCB on, and they seem to connect to some earth connections on the print. So I did power it up while it was out the unit, but it still didn't come on the display, so I'll put it back in just so that these screws that are sort of on this board, that one there and this one here, so that they could get the 0-volt power supply chassis connection through the chassis rail again if it needed that, because I wasn't sure. Just be careful as well, the main switch is down there, if you can see it. It's that's the switch there. It's got 240 volts on that, so if you go, you know, sticking your fingers on those connections down there, you're going to get a main shock. So just be very careful if you've got the front off and you've powered it up, that you don't touch that switch there with the brown and blue wires, because you're going to get fried. So yeah, that display is not on the backlight, so I'm sort of convinced now that whatever's happened has taken out a supply rail. It could be that bulb's blown as well, so I'm just gonna check this bulb to see whether that's open circuit, but at least we're getting a bit further now. Okay, so we're ready to some voltage measurements now. I've just found the diagrams for the display, which are these, and just having a quick look at it, it's quite obvious what's going on down in this area, which I'll explain. We've got 13.8 volts coming in here, and that then goes through an inductor. Now I'm about to see a bit better if I just zoom in a little bit, but possible. Right, so basically the output of the voltage regulator is 5 volts plus 5 volts DC, which is fed up to both driver ICs for the display, which are these two. Both of them get plus 5 volts from that regulator. But also, interestingly enough, if we just step back a moment, the input to the voltage regulator carries 13.8 volt. There's a tap that comes off and then goes to the centre tap of this transformer. Now, the upper part of the winding goes to this collector, this transistor, which is an NPN, and then the bottom tap of the transformer likewise goes to the other transistor. We've got an RC network for both transistors, so this is a multi-vibrator oscillator. So as one transistor basically pulls down this side of a transformer, for example, then the other is effectively switched off while this is switched on, so on and forth, and it just flips between them. So it's like a flip-flop, a multi-vibrator. The frequency and the time constant set by these RC networks here, and then the inductor, the transformer, primary windings, then obviously transform onto the secondary windings. We've got 2 sets of secondary windings there, actually 3 if we include this, which I'll talk about in a second, but both of these windings supply voltages to the display module. This winding goes in direct, however this winding goes via a dimmer circuit, which is this part here, which goes to a switch on the front to control the luminance of the display. So basically it just takes an output and then feeds it back so that it can illuminate the display differently. Now this winding here is quite interesting because this diode is arranged in a fashion where it's going to be a negative rectifier, so the voltage coming out of it will be minus voltage, and that's the reason why these capacitors are in the reverse polarization. And we've got a resistor there, and then we've got a clamp Zener diode which is across the rail to clamp this to minus 5 volts. So we have a plus 5 volts rail and a minus 5 volts rail, and if we follow the minus 5 volt rail it goes into the ICs as well, and obviously the same here. So both ICs get a 10 volts DC supply, because minus 5 subtract from plus 5 is 10. So we've obviously got 2 supply rails. So if we lose any one of those 2 supply rails, then we've got a problem. Neither the display driver ICs will work, nor will the display itself have any luminance. So we need to check the voltages getting to this 13.8, 5 volts out and a minus 5 there. So that'll be interesting. But I've already seen, when I've looked at this circuit, there is actually some evidence of solder work going on around the capacitors on the input and output of that voltage regulator. So somebody's already been to this level already. The transistors for the multivibrator oscillator are down here in the bottom. All these contacts you can see there and there are basically the transformer and the transformer windings. So it's all concentrated in this little area. And we've got 3 legs of a device here, 1, 2, 3, which is the 7805 voltage regulator. So what we're going to do, we've got the radio with the power button pressed in. We've just got to be careful to make sure the main switch doesn't make contact with the chassis, with the head being tilted forward. So I'm going to switch it on now. So the radio's on. We've obviously got the voltmeter down there, and we're good to go. So the inductor is across these 2 terminals, so that's the input to the inductor there, and we're reading 13.8 volts. The output of the inductor reading just slightly higher, 14.1 volts. The input to the voltage regulator, again that should be about the same, 13.8, and then the output of the voltage regulator, which we can measure on this capacitor, and we're reading 5 volts there. So that's good. So now I just need to find the diode, that minus 5 volt diode down there, looking at the PCB layout, if I can find that. I think it's around here somewhere, because we've got the 2 transistors which if I orientate it round properly, which will be this way around, I believe, yeah, and depends which way around it's showing. That's it there, yeah. So that's the, if you like, it'll be the way that they've done it. It'd sort of be, it's funny really, it'd be, it's like that way around, if you see where I'm coming from. So it's like an x-ray of the board but on the opposite side, which isn't particularly helpful. That's only useful if we've got the board laid that way, component side up. So it's when you're orientating, when you're reading it like that and then trying to transpose that onto the board, it's a mirror of it, so that's not particularly helpful. But yeah, if we've got the voltage regulator there, I'm just trying to find diode whatever it was called. It was called diode 6, D6. So I'm just trying to find D6 on that diagram, and I found it, D6. So it's more or less in line with that inductor, and diode 6 is just there, if you can see it. That's diode 6. So I need to find a piece of track that looks like that. Let me see if I can see that, because obviously it's a mirror, and just trying to find a piece of track that looks like it, and failing miserably. So I found an angle piece of track. I've got that. I can see that relationship. There's an angle piece. Yeah. There's another piece of track that goes down, then one that goes round. Yeah, I can see that. I can see where it is now. Diode 6 is, I think there's two. I'm fairly miserably at this, aren't I? Let's have a look. Diode 6 is actually there. That's the output of diode 6. There, look. Just on there. And what have we got? Nothing. Got anything there? Nothing. So that's where diode 6 is, and we've no voltage coming out of diode 6. So I now need to start looking at perhaps removing, if I'm on the right diagram. Which diagram is it? Oh, it's here, look. We need to start perhaps looking at now removing these that Zener diode and checking that, and then these two transistors, because this oscillator isn't running, and I can confirm that as well because these two windings, that winding on this transformer connect to the very end terminals of that entire flex strip down there. So if I now go on to that, and if you remember rightly, we had an open circuit on one of them, so just move that diagram out of the way, and then I'll just get on to that and that there, that terminal there, and with absolutely nothing at all. Just what, 2.5 millivolts there roughly on the meter, which I've just seen there. It's difficult to show you guys it at the same time as trying to get on the terminals, but we've not got any voltage there. So that means that this oscillator is just not running. So that's where we've been on effectively, these two just there, and this is diode 6 there on the output of that. And it's funny because that's where these big solder blobs are down there. So somebody's obviously been looking at that part of the circuit before. So anyway, at least we're getting closer now. I think, you know, if push comes to shove, we can remove the transistors and test them in the transistor tester. See whether the transistor tester will tell us they're working. And we can test the Zener diode as well and take it from there. Back soon. Okay, so this particular radio is well known for having an issue with the oscillator in here. I've seen people replace these transistors even though they're working because they sort of blanket change them. They use these two transistors as well in the inverter module as well, which we saw on the other side of the radio, which develops the different supplies. Anyway, top and bottom of it is that rather than replace these transistors, I've had them out, and I have known other people change them just even because the HFE values have been low. Anyway, I've had these out on the transistor tester out of the video, and I've tested them, and these two transistors are working. Anyway, I'm getting 30 volts coming in here anyway and going up this way, which I should have on that line there going out. So that reads correctly, so that proves the oscillator's running, this transformer's working, so I don't see any problem with that. So what I've done, I've moved on to the next stage now, which is this diode here, which is the rectifier in the formation that it will give orientation a minus voltage coming out, is then passed through this resistor and then clamped with this Zener diode, and this is a 5.1 volt Zener diode is that. So now that I've proved that's working, that diode, I've removed that and checked it, it's now time for this. So what I've done, I've set up an experiment here, which we can show now, where we've essentially got an external supply running at 14 volts DC, and then across these probes here we've actually got the Zener diode connected to that black probe, if you like, in series with that resistor. So basically we're doing an out of circuit test, if you like, to make sure that diode is delivering 5.1 volts. Obviously if the supply is connected across that the wrong way, then we'll get a full potential across the diode, because naturally its Zener function won't work, and thus the resistor will be able to pass the full voltage. And if a Zener function does work, we'll get 5.1 volts, or a voltage which isn't correct either way if a Zener does work. So we'll try that now. So basically I've got the voltmeter set up there, which you can see. We'll just go on across the Zener diode directly. If I can get my probes on. It's just a little bit difficult with this camera setup I've got. Right, so we're getting, if I can get on the lead properly. Oh, right, well that's good. We're only getting 3.9 volts. So that proves there's a fault. Yeah, so 3.8, 3.9, it's differing a bit, but there, settled down. So we're only getting 3.915 volts when we should be getting at 5.1 roughly, to 5.6. So obviously something wrong there. Now just to confirm that, if I invert the power supply leads the other way around, let's see what voltage we get then. So let's just have a look and just get on this probe if I can. So there we're getting the full supply voltage there, look. So that proves the Zener function does work, but it's incorrect voltage. So I'll just invert the leads back the other way around again, and then we'll go back onto this circuit that we've devised, and then go on to the Zener diode if I can get on it. It's always difficult with these damn probes. And then see whether we can measure this voltage. Oh, come on. It's a bloody meter. Oh, well, it's gone all together now then, hasn't it? 13.43 volts. Turn it round again, that way. Yeah, it's packed in all together now. Look, you see, it's by pulling on the lead there to manipulate it, it's actually lost its Zener function altogether. So I'll invert the leads back round the other way again, because we were in that position to start with, and then go on. So it's actually got worse as we've done the testing. If I can get on it. Oh, come on. Yeah, so it's stuffed. The Zener diodes have gone all together now, and that's just through mechanical strain, just pulling that diode a little bit there, the lead, so I could get a bit of separation. It's stuffed a diode all together now, so no matter which way around you run the lead, the supply, it's either reading plus 13 point something volts or minus 13 point something volts if you switch these round. So that's in a diode at the very start. When the lead was bent in the original position that it was in on the motherboard, was only regulating at 3.9 volts, which wasn't the 5.6, the 5.1 that it should be producing. And then just by pulling the leads out a little bit, just so we get a bit of separation, that mechanical strain in the diode has actually failed it. So this is obviously an age-related heat issue, probably over many years, decades of use. It's probably cooked itself, because of the way that it's in the circuit, it's clamping the voltage. So it's actually clamping it hard, because that's like an 80 ohm resistor. So we'll check that resistor as well, make sure that hasn't artificially gone high. I think it's an 82 ohm resistor. So this Zener diode here is shot. I'll check this Zener diode as well. We'll have that one out. That's a 6 point something volts, I think it is. If I have a look under my little magnifying glass and see what it is. Yeah, it's a 6.2 volt Zener is that one at the top there. So if we just go right in, you might be able to see that a little bit better. So that's a 6.2 volt Zener. That's obviously the one that we've just had out, the 5.1 volt Zener there. So yeah, a bit of a devil really, isn't it? But there you go, that's the way it is. So I've got some Zener diodes anyway in a box, so we'll just whip some of those out and do a test with that. Okay, so we've got some Zener diodes here. These are 5.6 volt Zeners, old stock things that I've had for years. Anyway, we've taken one of these out now, the 5.6 volt ones, and we'll just do a quick test. So again, we've got the setup where essentially we've got the meter, and we should be able to, if I can get on it. So obviously I'm working a significant distance away from it. There you are, look, we've got 5 volts there, so I'm happy with that. Nothing wrong with that at all. So we'll bob that in, then we'll use that diode in the circuit, and then we'll remove the other one, the diode 6 I think it is, which is that other diode. So worth doing that test. Right, we're back. So this time we've got the test set up with the next Zener diode, which is this, I can find it on here again, diode 3, which is this one. Now diode 3 is part of the dimmer circuit, this Zener diode there. It's a 6.1 volt Zener diode, and that goes out to this connector here. So with 30 volts DC as per this voltage reading on this line, and that goes to the front dimmer switch. So when we press the dimmer switch in, it brings this this voltage regulator Zener in to then limit the voltage in the circuit, obviously, where this transformer goes to the display, thus reducing the brightness. So we've done the same. We've got a resistor in series with the Zener diode, and I'll just zoom out so we can see you better. So that's what we've got here, the Zener diode there. It's written on the Zener diode, the voltage as well, when we look at it under the magnifying glass. So in theory I should have 6 volts roughly across there, and we have. It's a little bit weak, but it's near enough. I'm not going to complain about that. So we've got 6 volts there, so that proves that the Zener diode's working. I'm just going to put it under a bit of mechanical stress, just like we did with the other Zener, because that packed in the other one when we gave it a little bit of mechanical stress. It was the wrong voltage before, if you remember. It was reading 3 volts instead of 5.1, and then suddenly it read open circuit. Basically it was full supply across it. So anyway, that's maintaining that at 6 volts. So I'm happy with that. I'm very happy. Now I don't know if there's any other Zener diodes that are worth a check, worth a look. I think there are a few, but I think we've more or less done them all. That's important in the supply. There's diode 3, which is that one that we've just looked at now. We've looked at diode 6, which is just a rectifier diode. I've had that out and tested it. I've had diode 5 out, which is the 5.1 Zener, which is stuffed, so we put another equivalent into it. The electrolytic caps on the output there where my thumb is, we've checked those. I've had those out and checked them on the capacitance meter off the video, and they're okay. The transistors are fine. There's no other Zener diode in the supply line that I can see. There is diode 4 there. I might check that one next. That diode 4. So that's interesting. That's got I think it's a 24 volt Zener, that, because it's an RO24E, whereas the others are an RD24E, sorry, whereas diode 3 is an RD6.2E, and diode 5 is an RD5.1E. So I think with that saying a 24, it'd be a 24 volt Zener. That D6, I think it is it D6? No, D4. diode 4. So if I just zoom in, it's just there, look, that one, diode 4. So I'm going to check that next. I'm going to have that out of circuit. We'll put this diode back in, diode 3, which is this one up here. We'll bob that back in and we'll check out diode 4 now, and we'll just check that. May as well. We found one faulty, you never know, there could be more. Right, well, I've had to change power supplies now. We're testing 24 volts Zener because the power supply I was using before, its maximum voltage was about 25 volts anyway, so it was right on the limits of this Zener diode's spec. So we're using the Siglent 0 to 30 volts power supply now, which is nice and silent, and we've got 30 volts being supplied to the circuit. So if we just go on to across the Zener diode first, I'll just check to see whether we get 24 volts DC, which we should be, yes. So it's a 24 volt Zener, and we're receiving 23.21 volts, so nothing wrong with that. Obviously across the whole circuit I should get 30 volts roughly, if I can get on the contact properly. It's just difficult to do with these tarnished connectors. There you are, look, 29.98 volts supply, and then we've got 23 volts, so that proves the Zener diode's functioning. So that's the last of the Zener diodes anyway, in the supply circuit. So we've tested all the Zener diodes now that's got anything to do with the power supply. So we've tested pretty much all of them. There's that diode we've tested that diode, we've replaced that one because that was faulty. We've tested that diode and that was okay. We've had a couple of them out now, so a few. So I can't see any others in there really that could go wrong. So I'm happy that we are where we are, and I can now reassemble the unit and power it up to see whether it starts working. So fingers crossed. Okay, I'll put it back together again. It's becoming a pain, is this radio now, and powered it up and there's still no display. So what I've done off camera, I've done some voltage checks basically, and what I've done is I've established that while it's live in situ and powered on, we're getting the -5 volts going up there from this Zener diode that we've replaced, which we didn't have before because this was obviously short. I have 30 volts on this line here as decreed by this voltage here, and when I press the dimmer switch and it drops down to about 20 volts or whatever, so that's functioning. So that means this oscillator is running, and this coil is running, and that coil is running. So that's those three running definitely because we're getting the voltages. But then I went directly onto the display again on the end connections. Basically at the end of the display on both the first and the last pin is the doubled up pins which carry the current to the display. Now I wasn't getting any voltage at all there, which meant that either the track's broken between here and the transformer, or the transformer winding's open circuit. So what I did, I went across these two pins here with the multimeter in ohms, and I actually received 9 ohms impedance, or 9 ohms resistance. But there was no voltage at all, no AC or DC voltage, because I tried both. Obviously if it's switched and there's no rectifiers, then it should be AC, and this multimeter I've got can read up to about 400 kilohertz AC, so technically I should be picking something up. There's nothing there. So what I've done, I've unsoldered this transformer now altogether, and we've got that here, and I marked it on one side so I know which way to orientate it, since it's got the same number of pins on each side, and that transformer measures correctly. However, I've found another fault now, which is these two tracks. If I just try and zoom in to show you, you'll probably see on camera there are two tracks coming up. It's a bit difficult try and make them out at this stage, but let's see what we can do. Now, this track here goes to that pin, and the one beneath it goes to that pin as well. But what happens is this track here goes off and connects to this end connection, and that's open circuit. There's no connection between there and obviously there, nothing. So we've got a broken connection more than likely somewhere here. This connection goes right to the other end, the very end of this flex, and that's fine, that's okay. So there's an open circuit between there and there now, but not on the other side, which is really weird. I don't know why that is, but anyway, I'm going to run an enamelled wire from here to there now. But basically, the heater or whatever in the display is at 9 ohms resistance, and I'm only measuring 9 ohms resistance if I go between that connection and there on the good old multimeter, but not getting 9 ohms if I go across these two directly. So I managed to pin it down to that, because obviously when you've got the coiling circuit, the coil itself will read a low ohms resistance, and thus it'll interfere with the measurement of trying to find out whether it's the display that's open circuit or whether it's the coil. And obviously when you're trying to measure across the two connections on the transformer, across these two lines here, if you're measuring either at this end or at this end on ohms, you have if there's a broken connection between here, you're going to be measuring either the transformer's resistance or the display's resistance, but it won't tell you obviously if there's an open circuit in either conductor supplying power to the display. So you have to remove one or the other in order to check either the transformer independently or the display independently, and I've chosen obviously to remove the transformer. So yeah, this does look a very odd fault, I must admit. Anyway, we've got some lovely enamelled wire which I'm going to solder in now, and we'll put the transformer back in, and then we'll power it back up and just see what happens. Fingers crossed. It's a nightmare, is this one. Well, finally we've got the display on to some extent anyway, although when I turn the frequency control there's nothing coming up there, so I'm going to have to investigate further whether the segments are broken, because the ribbon flex down here has got open circuit connections. I mean, I could technically move it, but it's not changing anything. But if I press the which button is it now? I think it's that button there for 1 GHz. We get the 1 GHz thing coming up. We've got SSB lit up, obviously, AM, FM, so they're working. But again, it's this thing where if I turn the control, I just can't get these displays to illuminate. Now we do have a decimal points and we've got the dash. If I enter something in, there's nothing there, so apart from obviously if I change the modes. So all the mode indicators, they'll work. The dimmer control now works as well, so that's dim on if you like and dim off, on and off, so it's dimming the display as it should be, but no segments. So we could have open circuits in this bit down here. I'm going to check the supplies to these chips now just to make sure they're getting there. So we are a little closer, so yeah, it's just a weird thing, isn't it? Very strange fault. It's looking more promising. I just switched it off and back on again, but might be a data fault if I switch it off and then back on again. Let's see now, 6 something. Let's see whether I can 8, 7. It's random. So I wonder if it's like a data capture fault, maybe. It could be something. Just press a few buttons on here, see if I can get any response out of it. Turn the frequency control. They're working. I don't think the processor's locked up, because otherwise it wouldn't receive. So I don't know. Just pressing a few buttons on the front. The display is not changing anyway, no matter what I press. So it does seem possibly a data fault then, or a clocking issue, something like that, to the data strobing. Could be something like that as well. Interesting. Right, I'll read further anyway. Right, what I've done, because I want to be 100% certain that these connections on this edge board here go to the display properly and connect through that flex. If you remember earlier in the video, I've had lots of problems with this flex having no connection between the flex itself and where it meant to go on the circuit board, and one of the reasons why we had to do this patch job at the end pin here with a transformer in the last part of the video. As you can see, there's a few red wires here because we've got broken connections, which I've managed to prove. So I just want to go and definitely check that the rest of the segments on the display are all connecting to the places they should be on the motherboard here. Although they're connecting properly across the flex, I found out that some of them are not making it to the display drivers. So I've got to get that 100% working. So if there is another fault with the digital section, then we know with great confidence that this display is actually fully functioning and connected properly. Anyway, having removed this flex from these pins, because these pins stand up proud like that, and then the flex goes on them, and then underneath is another solder joint that's meant to connect these pins to the trace, the PCB traces. I'll put the magnifying glass on and we'll just go through it together, and we can see now what the true cause of this problem is. So we'll just put this magnifier on, and then we'll go right in and we'll zoom in on the M pin. So that's the M pin there, look, that we had the end wire. You can just see it to the top part of the picture, the repair job we did with that track, and the track's not broken, but it's not connected to that pin, obviously. And so that means essentially then that, you know, there's no connection. As a matter of fact, that pin, its neighbour, those three pins together, and indeed these on the island, there's no solder connection at all on them. And unfortunately, likewise, quite a few of these, you can see there's some tarnishing on there as well that you might be able to see. So again, you know, not particularly good. And some solder on some of them, but it's a bit, you know, how are you doing? And some of the pins as well are tarnished as well. They're actual broken, and the solder that connects to them, and there's little islands that they're in, like crevices, so a crevasse. So yeah, that's one part of it there. So again, if we carry on down, you can see again similar thing there. All these have all got that same problem, so it does seem a bit strange. Again, these are definitely problematic to those traces, and that one there has got some kind of terrible like island around it that's broken and cracked, like that one there is as well. So again, not at all good. It's not what you want, that. So this is the issue. So they'll all need soldering and redoing. Now, because we're looking down from above, the pins themselves, when we try and look at them the other way, they are physically black on one side, some of them. So again, it's this thing where they need cleaning up with a diamond edge file that I've got, and then re-soldering. So a technical manager might be joining us in a moment, but that will answer the problem as to why, when we zoom down here and we have a look at the rest of them, we've got some serious problems with the connection. Like all these, they're terrible, so they all need resoldering. So yeah, that's it basically. It's such a bad job, you know, really is such a bad job. So we'll have to clean them up and solder them and then put the flex on, and then I know then that we're 100% got continuity from the display unit to the traces on the PCB, because otherwise we're just going to be going round and round in circles. Right, I've resoldered them now quite nicely, and we'll have a closer look at them, but as you can see they're a lot better than before, and we'll have a closer look under the microscope and see what they're like. So we'll just do that now, and fingers crossed we'll be good to go with the putting the connector back on the flexi. Right, so let's get the light set up and move in with this camera, and let's see whether we've got decent. Yeah, that's a lot better, is that? Nice to connect it. It's that end one there, you see, that goes off then to that pin on the transformer. So obviously that's back where it should be now, connecting to there, and I'll just go along. I've cleaned the flux off as well with isopropanol alcohol, and that looks all good to me. Yeah, definitely looks good. Use that diamond edge nail file to get the tarnish off the pins before soldering them, so no problem there with the look of it. All these pins are nicely soldered, so we can at least look to put the flexi back on now. So absolutely. So yeah, much better standard than before. Definite improvement, definite. That's the end pin there. So yes, I'm happy with that. I'm very happy with that. Right, we've done a continuity test using the multimeter on the each one of these connections. Now we've put the flex back on. Now we had a couple of broken ones as we did initially, 2 or 3 at this side and a couple at this side, so they've been reconnected because the flex itself, a little island that the solder goes to, is broken away from the track that goes down here. So anyway, I've resoldered all those wires in. I've checked continuity from end to end all the way across, and we haven't got a problem. So I'm now ready to power it up, see what we get. Well, we've got the display working, but when we turn the dial here, although we can hear relay clicking as we go from one band to the other, and if I press that 1 GHz, which we can see, you know, the icon coming on, but it's I switch between the modes as well, as you can see there. You know, if I go between AM, SSB, etc. But as I turn this dial, I'm not getting anything. Now there are some earths that are on the board behind the display driver board that aren't made until it's screwed in place, so it could be an issue there. But I do notice at random when I power it up it'll display something different. So if I move that, not getting anything, although the radio is tuning up and down, so we can hear the relay clicking for different filters. See, now there's no frequency display. Switch it off again, switch it back on, and then we've got something there. But with the display now working, I'm quite happy with that. Very happy indeed. And yeah, so I can reassemble that now, and then we can start looking at other things. There's obviously some data error, because we should see the frequency change as I'm moving this. And even if I do a manual entry as well, I'm not actually seeing anything coming up. So I think we'll disassemble, well, we'll reassemble the board at the back, because as it says 2 eyelets on, which I'll show you now, which need to be grounded, and that could have something to do with this problem as well. So if the earths are not on the board in the right places, so we'll reassemble this driver board and go from there. So yeah, the earths I'm talking about is more particularly this one, because we've got an eyelet here that goes to the chassis of a radio, and obviously that connects to various components. Likewise, this one here, this has got mainly a big ground plane, obviously, which goes all the way around, down along here, and then all the way around the edges. So I think both of these will need grounding first with the screws, so everything put back in place before we go any further with it. Put it back in the case front, and then we can start moving and analysing other parts of the circuit. Back soon. Okay, I've done a little bit more digging on this, just probing around this board, looking at data and things like that, measuring voltages. And one thing that's strange that I found is the 5-volt voltage regulator that's here that supplies the driver ICs as well as other circuits. This is loose in the board. I couldn't believe it when I found it. So it just shows you, doesn't it, if you inspect. If I zoom right in here, you might be able to just see there these 3 pins. And if I grab hold of the board, the little 5-volt voltage regulators there, if I just move that board, you can see the pins moving there, look. And I'm just trying to get the camera more focused, and this land here connects to a capacitor that's been previously resoldered by somebody prior to me, and the capacitor itself is obviously moving on the board, so we're gonna have to sort that out. But yeah, the leads for the little 5-volt voltage regulator, they're definitely loose, you know, so that's not going to help. It just shows you, doesn't it, there's all sorts wrong with this thing. Right, just give this a resolder and back soon. Okay, the moment of truth has arrived, but I get it all back together again, and let's just see what happens. Okay, so we'll power it on, and we've just got this part of the display now. No frequency, nothing happening there, so maybe I've not fixed it then. Let's dial in a frequency. I'll put in 1, oh look at that, 4, 5, oh brilliant, .0. I did notice earlier, oh, and it has, look at that. I did notice earlier as well when looking at logic board, which I'll go into in a moment, the 3-volt battery for the memory retention is missing. The wires are there but no battery, so it's obviously been removed, so that'll be the reason why it's forgetting its frequencies when you power it off. Now last time I did have a frequency that was displayed earlier in the video, if you remember, and it was corrupt. As soon as you touched that dial it corrupted and then went off the display altogether. But let's see. Oh look, wonderful, that's marvellous. That looks like we've repaired that then, and the frequency's varying nicely as we adjust the control. No hiccups like before. So yeah, really weird. I've still got the display here to sort out, that backlight, and have a look at this meter, see what's going on there. I will test it though. I'll just put in 145.0 megahertz, because I've got this radio here that's on 145 dead, so just see whether it responds to the transmission. It does. Yeah, you can see the meter as I key the radio up, you can see it's definitely responding. So it's still receiving, although we will need to check all that anyway, so I'll just turn that off again. that radio there. Right, so yeah, very strange, but we were always getting these indications, like when I press the 1 GHz button there, we get that little red indication coming up. So if I zoom in on the display and maybe turn this off so I can see it better, I was always getting these little indicators as well, like AM, FM, SSB. They were always working, but the frequency wasn't working. And then we had, you know, the dimmer functioned, obviously. All the other things functioned. So that looks like it's priority channel. And then you can set the frequency for the priority channel. Just having a tinker to see what all the other buttons do. And I think there's a scan mode on it as well, but I'm not sure how that works. We'll have to look at that. So yeah, really weird. So if I put in the frequency 145 megahertz in, and yeah, so, but what was strange about that is I'd already done measurements of voltages on the PCB, and if I get the right diagram here, yeah, that's the one. So I'd already, that's the little 5-volt voltage regulator there, and I'd already measured the voltages round here and they were all okay. We were still getting 5 volts being supplied, no problem there. We measured that earlier, but obviously touching the probes on the leads of the voltage regulator will have made it make connection again. It's not until you look under a magnifier that you see the broken pin or connection, and obviously that supplies voltage then to these two driver ICs. And I'm sort of chasing my tail around a little bit because we got voltages here restored. If you remember earlier, we had a broken connection on the secondary winding of this coil leading to the display, because although it doesn't illustrate it here very well on the diagram, it goes through a set of pins which had a broken PCB island connection to a pin, and then the pin on the end of the pin solders to a flexible printed circuit which then bends like a piece of paper to the display, the glass display, which then solders then there. And of course we had all sorts of open circuit connections on different pins on that display as well, which needed about 6 enamelled wires to bridge the connections from one side of the display right to the other side. But I did actually start looking at the logic board, because obviously the logics for the different symbols like the gigahertz and the AM, FM, etc. switch by these. So that'll explain why the indicators themselves for the display, the gigahertz indicator, etc., and the AM, FM sort of things were all working, but the no frequency display. But yet this was working always at the end. So I assumed these probably weren't getting the right driver information from the microprocessor, and I started tracing back the data lines that come from the microprocessor that obviously strobe with data that could drive both ICs, you know, obviously with these connections, that then obviously strobe the lines to the segments on the display. So I then traced it all the way back then to the microprocessor and started looking there. And incidentally as well, I found something else quite interesting about the microprocessor. It's got near it some connections for the band selects as well, little jumpers, which we're going to look at, because I think that widens its frequency range up. But anyway, I traced the data lines coming in right the way up then to the, you know, the sort of microprocessor and what have you, and data lines, and I thought, well, the microprocessor must be okay, because it's responding to you know, me dialing in a frequency on the, you know, on here on the keypad. So, you know, obviously if this wasn't working, then I then would probably have my rights to look at the microprocessor. But obviously if you can dial in something there and it responds by receiving a change in frequency, then the microcontroller's running, you know, the processor's fine. So I sort of came back then to that display board, but this flexi had loads of broken connection. I think 3 on this side and 3 on this side. Obviously, because the board's been in and out that many times, this has flexed loads of times and it's broken the connections right where these little islands solder to the gold contacts, that the connections that go from one side to the other. And of course these flexes are terrible, because when you bend them in one position they'll make contact perfectly, and as soon as you move them slightly or flex them a bit, then they'll break connection. So we had that painstaking task of measuring them all, but that was all for nothing anyway, because the pins that are down here on the PCB that we looked at, these islands, so you can see here, where they're meant to solder to the pin that comes through these holes, they were cracked and broken, if you remember when we were looking. So we had to unsolder all this again, resolder all this, put that flex back on, bridge all the broken connections again using the enamelled wire that we got in order to re-establish connections. So it's like a two-part connection problem really. Probably caused by the whoever looked at it before flexing this a lot, having the board in and out, trying to do fault diagnosis. It's obviously broken this then, and the faults then progressed, and probably got fed up with it, rightly so. So yeah, very strange little problem. You know, it was such a weird little thing. And of course this little transformer thing round here, that was running at 30 volts. So we're getting all the supplies with the look of it, but in actual fact we weren't, because obviously this little 5-volt regulator. I know we had a problem with the Zener diodes, and I was really hoping that when we found the problem with this 5-volt Zener, I was going to fix it, because I could tell straight away that Zener had popped. The rest of the Zeners that we took out here, there and everywhere, they were all okay. Various Zeners that we then removed and had a look at. But it's a very strange fault, that, very strange. So a bit of both really, caused by somebody's excessive, you know, fault finding on the board, moving the flexi about, damaging that, combined with then the voltage regulator having dry joints on it, and all the dry joints that we had on the pins here for the display. Such a weird thing, you know, I wouldn't have expected it but to be so problematic in that area. And I've seen videos as well where people have changed, just blanket changed these components, where is it now, round here, these two transistors and capacitors and things, to get the display back. And I'm sure that does happen as well, where they go faulty, and then obviously you know, you're having to change those devices maybe. But certainly not in this case. I never get the easy faults, me. I always get the nightmare ones. Everybody else gets the easy faults with the look of it. But yeah, so very strange. So what we'll do now, I'm just going to probably change the backlight bulb in there anyway, just to get that going. I don't know why that meter's reading that level all the time anyway. It seems to be reading a minimum level there, so I'm not sure why that is. It could be that somebody's been fiddling as well, so I might have to check the alignment. And we'll put the SIG-gen on, check the receiver on all the modes, AM, FM, SSB, etc. We'll make sure that's all running, and we'll check its frequency range. The 3-volt battery on the logic board's missing. The wires are there, but there's no battery, and that's for the memory, for the RAM, so it can remember the memory channels when you turn this dial. You know, obviously it's forgotten them all because they're no longer there. Is that, well, it's at 220 megahertz, yeah. So we'll have a look at that. I think yeah, I think that's the next thing, spec test, and take it from there. Right, before we do any alignments, which is quite in depth on these, I just want to do a quick spec check of its sensitivity and frequency accuracy and modes of reception over its entire frequency range. So we'll just have a little quick run through. So I'll just put in 25.0 megahertz. We'll select, let's have a look now. That's SSB, that's FM narrow. We'll just select FM narrow. And then what we've done, we've got the speaker on the back of the radio connected out to the scope in on the Roden Schwartz radio test set, so we can read the AF waveform coming out the what will be the speaker, the receiver, and we can get synod and distortion measurements as well, and then we can check receiver sensitivity. So I'll just put in a frequency here of 25 megahertz, and already receiving a level at 0.2 microvolt. So it's very sensitive already at 0.2 microvolt, but I'll just crank it up because we've got the squat set quite low. So we're looking about got 12 dB point here at roughly there. We're looking at 0.2 microvolt for 12 dB synod, which is pretty good. There's obviously FM wide as well. So if I do AF1 and set it at 4.5 kilohertz, so 1 kilohertz mod at a level of 4.5 kilohertz, you can just about hear it, but that's for FM broadcast really. So 100 kilohertz. There's something there, but I don't think that's performing as well as it should be on FM wide or just FM. Obviously on FM narrow it's too wide, and if I reduce it to 4.5 kilohertz it's still too wide. But if I adjust that then to 2.5 kilohertz, then we're picking it up. Notice the signal meter's not measuring very well until you get the level really high up into the sort of 10 microvolt range before it reads roughly an S3 or whatever that is there. So you need about 10 microvolts really in order for it to just show sort of a minimum in the signal. So I know that definitely needs adjusting. Okay then, so we'll go set RF frequency. We'll try 100 megahertz now, and we'll key in 100.0 megahertz. Just tweak the signal down. Okay, we'll just check AM, and then we'll do set mod at 60%. Just find out which is a percent key on there, which is the top one. So that's 60% mod. So just wind the RF level down. Now into the microvolts range. So still the same sensitivity. Just a little bit more depth, but not too bad. SSB. So we'll then go to SSB testing. And what we'll do, we'll go to set RF frequency under RX SSB. 100 megahertz. We're on lower sideband at the moment. So we're just looking for a mod frequency around about 1 kilohertz. Which is about there. So that's fully functional. So we'll try upper sideband. It's about there, nothing wrong with that. I'll go back to FM narrow, and then we'll just go back to RX test. Okay, so nothing wrong with that. Right then, I'd like to now try 300 megahertz, and then again set RF frequency 300 megahertz, RF gen level. Just wind that down. Still very good sensitivity there. Nothing wrong with that. Okay. Right, let's try 500 megahertz then. And then again set RF frequency here. 500 megahertz. RF gen level. Still good sensitivity. Although it's less sensitivity on 500 megahertz, so I'm just going to vary the frequency. Let's see whether it picks up a bit better. Yeah, it does, you see. I think the reference oscillator's off a bit, and it's because it's got a better sensitivity at a lower RF frequency. So yeah, so I think the PLL might be off a little bit, or the reference oscillator might be, because if we put that bang on 500 megahertz, we've totally lost the signal there, and we have to increase it. So it's as if the RF carrier that the test set's putting out, the receiver is reference oscillator or PLL slightly off frequency. So in effect what you've got is you've got the accuracy of the test set against the inaccuracy of the receiver. So we just need to bring the receiver's PLL more reference oscillator, adjust it so that the signal, the reference is perfect or near perfect, so that the mixer frequency is bang on, because it's a little bit lower than where it should be. Anyway, at least that's shown itself, we know that now. Obviously again AM mode, 60% again, so nothing wrong with AM, that's coming through, so that's fine, no problem. Okay, so what I'd like to do now is I'd like to go up to 900 megahertz, set RF, sorry, clear, set RF frequency 900 megahertz, and then do 900.0 megahertz, RF gen level, and then again doesn't appear to be receiving anything really, not much. Quite poor, it's quite poor there, isn't it? It's taking a good several microvolts. Just do set RF frequency, adjust it down. Yeah, you see there, look, it's off frequency. Here's the receiver, so again phase lock loop lock issue there with regard to the reference oscillator. We just need to get the reference oscillator, just wind the RF level down now, find its peak frequency. So it's improving still, and then it should start to degrade soon. And we are in 1 Hz steps. Oh yeah, look, it's starting to degrade. So the frequency is about there, I would say. So that's quite a few kilohertz of frequency in order to get the receiver to be more or less in spec. So again, we've got the test sets carrier sort of here at 900 megahertz. However, this receiver's sort of down here by a few kilohertz. So obviously when we bring the test set frequency down to match this, what the reference oscillator is running at. Obviously if a reference oscillator in the radio is running off frequency, then it will mean that because it's a reference to the rest of the system, then the rest of the system will be off frequency with it. So once we adjust the reference oscillator frequency back to where it should be, then the receiver will be then receiving the frequency that the test set gives out, and we won't have to increase or decrease the frequency in order to improve the performance. So I'm happy with those measurements so far, up to 1 GHz. I've got a microwave signal generator here that we can use then to test the next phase up to 2 GHz, and that would then test the specification there. So we'll set that up next and try that. Okay, so the next measurement is to set the radio to 762 MHz, put a mode in of FM, narrowband, apply an RF signal to the antenna connector at 5 microvolts then, which is equivalent to -93 dBm, with a deviation of plus minus 3.5 kHz at mod frequency of 1 kHz. And then we look at the meter on the display there, and we need to tune these inductors both in the RF section and in the IF section. So there's L57 and 58, and they're located just here. You may be able to see them. There's one just peeking there, hiding away, and that's the other. That's L57 and 58. So we have to adjust those with a non-metallic adjustable trimmer to get maximum signal on the meter at the front. And then also there's L4, L14, L5, 6, 7 and 8, and they are these coils. So the sort of if I remember rightly on the diagram, L14, 5, 6 and L4 is like it's like that one there next to these two crystal filters. That one there is L14, okay. The one diagonally across from it that's there is L5. Then L6 is one straight below it, which is this one. L6 is that one. And then L4 is back to the other side of these crystals to the left there. That's L4. And then L1 is just below this connector, just there. So that's L1. That's for FM wide adjustment, which we'll probably do later. But basically it is that one, these two, and then that one there is L14, L5, L6 and L4. Obviously L57 and 58 are these. And then the IF gain adjustment as well as part of that, obviously being L8, L7 and L11, which is a measurement we do after this, are these two. So if we just move the camera back a bit, so that's L7, that's L8, and this one up here is L11. So according to the information, we need to start adjusting those, but before we do that, let's get our non-metallic trimming tool. We're going on to these two here, and we're going to, as per the manual, once we get our trimming tool settled on those cores, we're then going to look at the meter. And the idea is, of course, to turn the cores and peak this meter here for maximum. So if I turn this core this way a bit, as you can see it's diminishing, and then we'll just peak it there. It's starting to go again, so we'll back it. I think that's the maximum we're going to get out of it there. Then we'll move on to the next coil, which is just hiding down there, L5758, and then we'll do the same there. So that's diminishing, going that way. That's peaking there and then diminishing, going that way. So I'll just wind it back a bit and just set the gain there. That's the maximum we're going to get out of that. Then if you remember, it was this. Now in order, it did say in the manual, when we read it, it did say, it didn't mention about doing them in order, but it's recommended, I suppose we do, is L14 first. I think, no, L4 is first. So L4, according to the diagram, is somewhere knocking about. Where's L4? L4 is on the output on the left side of those crystal filters. So basically L4 is this one here. That one, that's L4. So allegedly for the IF gain adjustment, let's just have a look. Some of the cores are more difficult to turn than others. That's it. So again, peaking on the meter, peaked it there. Don't think we're going to get any better out of that. I think it's going to be more difficult than you think, actually, trying to get anything more out of that. So yeah, it's diminishing there, climbing up, about there's maximum we're going to get out of that. Then it suggests adjusting L14, and L14 is L14 is the other one on this side there. That's L14. Again, peak that for maximum, which is there. And then from L14 we go to L5. I think that's L5, just check. Yeah, L5. And then L5 is this one here. That's L5 according to the info I've got. Yeah, so we'll try and peak that as well. Well, I'm just going to get there. Yeah, L5. And then after that, I think it said after L5 it was L6, if I'm not mistaken. Yes, L6. So then L6 is this one below it. That's L6. Just being careful not to force the cores if they're a little bit stuck, but be about there, yeah, just there, look, that's maximum we're going to get. And then after that, I think it was L whatever it was, let's have a look, flicking between diagrams, L7 and 8 after that. So L7 and 8 is L7 is this one here, and then 8 is this one just there. So that's L7. Again, try and tune for maximum smoke, and we're getting a bit more there. You see we've got something there, then a bit more there, and then it goes again. So just tune it for maximum just there, which is there, look. And then the next one is this one. Not really getting much adjustment out of that. That's at the top of the car now. So I'll just zoom in on that signal meter so we can see together, can't we? So that's the core being adjusted one way. So you can see it's starting to diminish, and then we're going up the other way. There seems to be just a sudden peak, but it's yeah, it's as much as we're going to get is there. We're not going to get any more than that there. Okay, so the next one is, that's L7, L7, 8, and then we go to L11. Now L11 is a different measurement. We connect to the rear panel an AC millivolt meter to the external speaker jack with an 8 ohm speaker, and we adjust L11 then for maximum AC voltage. So basically it's because it is in FM narrow, yeah. So L11 is probably the discriminator core for FM narrow, and L11 is this one. Oops, is this one here. That's L11. Right, if I zoom out, what we've got on the meter here at the back is the oscilloscope. We're connected to a loudspeaker, which if I flick the switch off, just this speaker here, and then on the output of that speaker I've got a connection then to the radio tester on the AF jack just here, that BNC, and then we're reading the AF millivolts there, AF voltage. Obviously it's a volume, so if I adjust the volume control then we can obviously increase its level. So we need to tune that according to the information for maximum AF level. So we're reading, I've got distortion on as well, reading 4% distortion at the moment, but AF wise it's 843 millivolts. So we need to adjust this coil then to see if we can get higher than 843 millivolts. So anti-clockwise it's diminishing, because we started at 843 millivolts. We certainly don't want any less than that. And then it's starting then to sort of go back the other way. So we need to adjust it quite carefully. I think it was already tuned quite well. And so I don't want to make it any worse. Just leave it to settle a bit. Yeah, we're not going to peak it any more than that. Yeah. Although if you look at the distortion, we were getting a lower distortion there. Look at 3.5, but 823. Then it starts dropping again, so it's going to peak around about there, I'd say. Right, we'll leave it there. So that measurement's done now. Okay, so that's the end of that page altogether. Hang on, there's just one more, which is FM wide mode now. This one at the bottom. So basically it says same frequency, same mode FM, but this time wide. So we'll select FM wide now on the because that's FM narrow and that's FM wide. And already we can see the AF waveform has reduced. And then same level, -93 or 5 microvolts. This time 3.5 kilohertz deviation still at 1 kilohertz mod. So exactly the same measurement conditions as before, but this time we adjust L1. And if we remember, L1 is sort of just below the connector, which is here. That's L1 there. And then we just need now then to adjust that so that we get a maximum AF level. So if I I'll just increase the volume just so we can see it a little bit better there. So we need to tune that then for maximum with the look of it, and it's not doing much. What does it say in the measurement? Oh, this way we look at the front panel and connect an AC millivoltmeter to external speaker jack with 8 ohm speaker, and then we're looking for L11 to adjust it. Actually, I've just made a mistake, believe it or not. That's L11, which is the step we were doing before, so I've just made a mistake. L11 was to adjust that meter for maximum. So I shall retrace my step, so at least you can see I make mistakes as well, and I just need to tune that then for maximum RF level, where we were before basically. On FM narrow. Just peak it. So yes, I made a mistake with that. I did. I made a mistake with it. But have I though? I mean, it says here L1 there and L1 there. L11. Where's L11 then? I've confused myself here. L11 is over there. Oh no, I haven't made a mistake after all. It is correct. Yeah, that's right. So it was FM wide, and then it was that inductor there. So I haven't actually made a mistake at all. So it's me getting sidetracked. So we adjust that then for maximum AF level. So it's currently 193 millivolts. And it says front panel meter, and then we adjust that for maximum. That's correct. Right. That's where I got mixed up, because they've got L11 and L1 next to each other measurement. So we observe the front panel meter in FM wide mode, and we turn L1, which is what we're on now, L1, and we turn that until we get the maximum signal on the meter. So it's obviously worse there. Turn it up, keep turning, it's getting worse, so back it back the other way, and we're almost there. Yeah, that's it there. Not get any more than that. So I'm happy with that. So that's that page over and done with after that little bit of confusion. And now we're on to the next section, which is to do with the first IF mixer. So we'll work through that next and sort that out. Back soon. Okay, we've reached the end of the repair video. The technical manager's here. He's given a seal of approval for us to continue into the next chapter of this video, which is alignments. The technical manager's been tuning around on the radio and just made sure that the receiver works as it should do. So we'll now move on to alignments. Now this next chapter of the video is actually quite lengthy, and it's lengthy for a reason, simply because we have lots and lots of alignments which ICOM prescribe for this receiver, and that's mainly due to the fact that the receiver contains many boards, and each board has its own alignment procedure for all the different frequencies and all the different modes. So it is quite a long drawn out process, but it is definitely necessary in order to make this receiver work as it should, as per the specification in the manual. So it is worth looking at this spec and the alignment procedure. If you want to do it yourself, it might give you the confidence to do it, because it is quite a lengthy process. Obviously we'll continue to use the Marconi radio test set, but any SIGGEN and cyanide meter or oscilloscope will do just nicely, and voltmeter, and we'll go through the alignments procedure. So onwards and upwards. Okay, insofar as alignments are concerned, we've already been through in the early stages of this video some alignment procedures, which are the main ones. Now, I've decided, although I filmed the entire alignment procedure, which took many hours from start to finish, even with editing, it was very difficult to try and get it within a reasonable time scale in this video. I decided that I'd cut out most of the alignment procedure because it goes on and on and on. You'll see, because we've not only got the diagrams which show us the alignment locations on all the boards, we've then got this procedure, and as I say, multiple steps per page, and again more steps. And I've been through all these, filmed it, did all the alignments and the measurement points in reference to the diagrams, and again more alignment references, more alignment references, and then some more tables. Been through all these and done all these, and then this table as well. So as you can imagine, setting up measurements for each one of these takes at least probably 5-10 minutes to find where we need to go on the board, connect the probe, then set the test gear up to make the measurement. And although I filmed it, depending on how people feel, I might follow this video with the alignment section, but by God is it boring, and it goes on forever and ever and ever. So I decided to omit it out this video. But as long as you follow this procedure, the alignment procedure that's in this manual, and you go through all the steps, it tells you whereabouts on the component to connect your test probe, which pots to adjust and things like that, and obviously go through each stage again, reference points for where you should take the measurement and where you should connect. There's all kinds of information which you have to very carefully go into, so I don't think it's really fruitful to go through that. I mean, it is a basic chart and you've just got to go through it one step at a time and verify the measurements and do that, and then obviously make the adjustments and tune it up. Having been through it all, it's very lengthy and very exhaustive. My recommendation is, if you're going to do the alignment procedure, have patience and just do it a page at a time, and then have breaks and then come back and carry on, because you'll be at it all day, and I literally was doing this. But it's worthwhile doing the alignment procedure, because obviously, you know, the alignment's necessary, especially if it's not received an alignment in decades. Chances are it will have actually drifted off slightly, as this one did. Obviously, yeah, a lot of patience is required with the alignments. I'd say this particular receiver is more involved in alignments than many other receivers that I've come across. This obviously is quite an old receiver, so therefore there's more adjustment necessary. There's a lot of potentiometers down the middle here which set up parameters for the varactor tuning in the bandpass filter, because the receiver operates with bandpass filters. Not only does it have like Collins filters in it and IF filters, crystal filters, but it's got varactor front end tuning, and that's what these potentiometers here do. They tune the front end here, and the measurement points, as you can see here, the references for the feed through connections into this can are actually on the right side, and you have to get on them in the right place, and then we have to adjust these potentiometers in order to tune the varactor side, and that is actually quite involved, is that bit, because the space that you have to work in is quite confined. There's also quite a few screening cans to remove. On most of these boards, there's a screening can that covers some of the sections, and they're soldered in place. Certainly on one of the side modules there's screening cans down here which are soldered together, and you do have to remove the solder for those in order to gain access to the components underneath and tuning. It's fully recommended, as I've said earlier in the video, that when you're tuning some of these cores, obviously you must use non-metallic trimming tools, and not to force any cores. If you're not going to shift, make sure that you just put a dab of isopropanol alcohol on them, leave them a minute or so just to soften up, and then obviously try and twist them then, but don't try and force them because you will break the cores. I've got some ceramic trimming tools as well here, which I use for some of the other cores. There's a mixture of cores, there's ferrite cores on these, then there's metal sort of screw type cores that are on the higher frequency UHF and microwave bandpass filters, which are proper metal slugs that you can tune. And there's also trimmers as well, variable resistors, and because the variable resistors haven't been turned in many decades, sometimes when you're trying to adjust them from afresh, the adjustment or the value goes way off. So it's better to wipe the wipers using a few turns fully counterclockwise and clockwise with a trimming tool, just to wipe the wiper on the variable resistor and then set them after that, otherwise you get erratic readings. The crystals for the local oscillator, first local oscillator, second local oscillator, for the different oscillators, the PLLs, I found they drifted off on this receiver, so they needed to be adjusted. So there's a few adjustments in here to set up the local oscillator 1 and 2 on the phase lock loop crystals, which are fixed frequency crystals that are doubled up, and there is an inductor and capacitor near those crystals to tune them, to net them to frequency. So that's an important adjustment. The rest of them are just pretty straightforward, adjusting resistors, caps, inductors to, you know, make the measurement. So that's it really. I don't think there's much else I could add. Quite an involved receiver, very difficult to repair in terms of the fault with the LCD display. Quite a challenge, as you no doubt you've seen in the video, and you get led off down different avenues. In my case, obviously somebody else had a look at the receiver before we managed to get to it, so again we were sort of trying to fix other people's errors, and although they've done their best, they actually put faults on it. And so, yeah, this is the issue that you get when somebody else has had a go at something before you have. But anyway, at least the boards were there, which is more than I can say for some other things I've repaired in the past, where somebody's had a go at them first. And I've enjoyed the repair. You've enjoyed watching the video, and I think it's sometimes more about the journey rather than destination. My videos are not edited in any way. What you see is what you get, you know. It's not a 20-minute wham bang thank you ma'am kind of video and straight to the fault and we'll fix it and we know what it is, you know. Fault finding is a methodical process, and sometimes it leads you off down all kinds of different roads, as we've seen today. So with that, I'd like to thank you very much for watching the video. By all means, leave comments below. I always welcome that. And if you like the video, please subscribe. There's obviously going to be more repair videos up and coming. And from me and the technical manager, thank you very much for watching, and we'll see you in the next one. Bye for now.